The OSI model. This work is licensed under Creative Commons Attribution. The Open Systems Interconnection Model is a layered framework for the design of network systems that allows for communication across all types of computer systems. It consists of 7 separate but related layers, each of which defines a segment of process of moving information across a network. The OSI model is built of the 7 ordered layers. Layer 1 physical, Layer 2 data link, Layer 3 network, Layer 4 transport, Layer 5 session, Layer 6 presentation, Layer 7 application. The figure shows the layers involved when the message is sent from device A to device B. As the message is sent from device A to device B, it may pass through many of the intermediate nodes. In developing the model, the designer distilled the process of transmitting data down to its most fundamental elements. Peer-to-peer processes. Within a single machine, each layer calls upon the services of the layer just below it. Layer 3, for example, uses the services provided by Layer 2 and provides the services for Layer 4. Between the machines, Layer X on one machine communicates with Layer X on another machine. Layer of this machine is communicating to layer of this machine. This communication is governed by an agreed upon services of rules and conventions called protocol. This process on each machine that communicate at a given layer are called peer-to-peer processes. Communication between machines is therefore a peer-to-peer process using the protocols appropriate to a given layer. At the physical layer, communication is direct. Machine A sends the stream of bits to machine B. At the higher layers, however, communication must move down through the layers on machine A over to machine B and then back up through the layers. Each layer in the sending machine adds its own information to the message it receives from the layer just above it and passes the whole package to the layer just below it. This information is added in the form of headers and trailers. Headers are added to the message at layer 6, 5, 4, 3, and 2. A trailer is added at the layer 2. At layer 1, the entire package is converted to form that can be transferred to the receiving machine. At the receiving machine, the message is unwrapped layer by layer, with each process receiving and removing the data meant for it. For example, layer 2 removes the data meant for it and then passes rest to layer 3. Layer 3 removes the data meant for it and passes the rest to layer 4, and so on. Organization of the layers. The 7 layers of OSI model can be thought of as belonging to 3 subgroups. Layer 1, 2 and 3, that is physical, data link and network layer, are the network support layers. They deal with the physical aspects of moving data from one device to another, such as electrical specifications, physical connections, physical addressing, transport timing and reliability. Layers 5, 6 and 7, session, presentation and application, can be thought of as user support layers. They allow interoperability among unrelated software systems. Layer 4, the transport layer, ensures the end-to-end reliable data transmission, while Layer 2 ensures reliable transmission on the single link. The upper OSI layers are almost always implemented in software. Lower layers are the combination of hardware and software. In this figure, overall view of OSI layers is given. Data at layer 7, the process starts out at layer 7, then moves from layer to layer in the descending sequel. At each layer, except at layer 7 and layer 1, a header is added, and at layer 2 a trailer is added. When the formulated data unit passes through the physical layer, it is changed into an electromagnetic signal and is transported along the physical layer. Upon reaching its destination, the signal passes into layer 1 and is transformed back into bits. The data units then move back up through the OSI layers. As each block of data reaches the next higher layer, the headers and trailers are attached to its corresponding sending layer and are removed. Thank you.